So starting from this line, most likely is for, I would say, additional information again, and then it's given to for those who we want to drill into the machine learning because they are full of mathematics and then they are full of, I would say that non-layman presentations, mathematical presentation for all the new network. So yeah, how the tuning and learning is performed inside the new network. So for example, you have an image of the cat, and then you have the machine learning model of cats, dogs, bird, and then they have different score. So the different score will be summed together, and then according to the distributions of the sigmoid, and then you will have different probability. So we try to sum up all this kind of the probability entropy of the cats, dogs, and birds. So yeah, you have yeah, 20 something for cats, and then 7 something for dog, but will be 0.368, and then we sum them together, totally we have 27. And then the probability to say is a cat should be 20 over all of them. So it will be 20 over 27. So the percentage will be 0.721, 72%. And then cat is 72%, dog is 26%, and then yeah, bird is less than 1%. And that is how the probability is calculated. Or we say the confidence to say the accuracy of is a cat. This kind of the calculation we call it softmax. So the softmax calculation will say that the most important thing will dominate the base here, the base of the probability, and then yeah, you try to give a score to your accuracy, give a score to your probability. So this one is called softmax. So if you can understand previous learning process of the neural network, so here we'll use another kind, we say that mathematical way to represent the situations. So suppose there is no activation function, so there is no sigmoid, no tangent h, no all these kinds of the nonlinear activation function. We just summarize all the things and then calculate the I would say that how we can turn the slope of the 3, 2, 4, this kind of random value, this kind of weighting. So the method is called propagation. So there are two ways, backward and forward. So whatever is backward and forward, the easier understanding. Again, after you have the randomized, the first one you have the randomized weighting, and then you have the new error, and then the new error. So they will use the new error and then calculate all the weighting again, calculate all the weighting against, and then they have a new values of the weighting. And all this kind of new value of the weighting is by tuning the slope of your linear equations. Okay, so there are lots of slope here, and then they just tune the slope. So the biggest value will be more responsible for the error. So the slope, the change of the slope will be bigger. The small value, so they have a less responsibility for the error. So the ratio of changing the slope will be less. So this kind is called how the ANN learns inside these equations, and then how they learn again is turning the slope. If you want to learn more, so there is a playground.tensorflow.org. You can learn more. Again, additional information in mathematical representations. In our course, I'm not going to ask you to remember all the mathematical formula because you are only the healthcare student. You only understand the concept is okay. And then, yeah, you say that we are randomly control the slope in each one. So random may be not perfect. Sometimes when we control the value and then they will fall into the local minimum. For example, here we just randomly tuning one slope, right? So maybe it's not the best answer. The best answer, maybe you need to have a big jump to go to some error, biggest error, and then finally you can go to the another better error, lower. This one is global minimum. Yeah, that is a common problem in the machine learning because we are fine-tune all the weighting a little bit. So it will be easy to fall into local minimum because we haven't searched all the possible solutions. And we always fine tune within here, and then without a big jump, we cannot go to the another highest era. And then if we cannot search all the things, maybe we will miss the local global minimum, and then maybe we will miss the best answer. And that is the situations of machine learning. So if you understand the neural network, and then the neural network that we have learned is really simple, and then structure is really light. So honestly, when we always say deep learning, deep neural network, deep. So how deep? So similar to our previous example, register 1, 2, 3, 4, 5, 6, right? So it should be 28 times 28, and then almost to 800 input layer. But honestly, for a simple, very simple neural network to identify some object or identify some biological image, so most likely this kind of the input data will be more than 100, maybe 120 and then 150, something like that. So you can imagine how difficult is the neural network, and then how many hidden nodes and then hidden layer are inside the neural network. So easiest one, perhaps you can prepare no less than 150. Maybe you have 150 hidden node in each layer, and then you contain at least 1 to 3 hidden layer to modify the whole solutions. Again, more nodes, more hidden layer can help you to maybe it's because all are random process, so maybe you can have a better solutions. But at the same time, you have to pay more computation power. You have to pay more time to train your whole model. So let us discuss. We have learned the deep learning. We have learned the artificial neural network. Honestly, artificial neural network is only one of the tools inside the machine learning, inside the AI. So we have the support vector machine, we have the linear regressions, we have lots of these kind of tools inside the inside the machine learning, inside the AI. And then the machine learning can be classified into different parts, right? Supervised learning, unsupervised learning. We will touch next week. And then we also have the reinforcement learning, etc., etc. So the CNN or the artificial neural network is only a tool. It can be applied in supervised learning. It can be applied into unsupervised learning. It can be applied into reinforcement learning. It's only the tools. They can solve different AI problems. Okay, so that is interesting. And then if you want to have a look with a bigger part of the AI, bigger part of the data analysis, you can have a look with it. So the more complicated model, more data, bigger model, of course you can have a better accuracy, better result. But if you have a better result, this means that you need more computation power. And this kind of computation power will be exponentially increased. Okay, so you can say that collect. Except remember, later on we have example of cats and dogs. If you only collect 50 image, so you have quite good result to identify cats and dogs. But of course, if you put a really special cat or really special dog, still they cannot identify the cats and dogs. And then you need to collect more and more data. With more and more data, and then you need more time, more computation power. Yeah, this one we have discussed. So we just use cat example again. So for the car, I guess the car is more easier to understand because car have wheel, car have windows, car have door. They have some common low level feature, and then low level feature can be combined into middle level and then combined into high level. For example, low level feature of cat, so it's only a simple patterns of some parts of the of his head. Okay, and then if you combine into middle level, so a bigger picture will be happens. If you combine into a high level, so you can identify this one is eyes, this one is nose, and then this one is ear, etc., etc. Yeah, and then we have discussed this part. I don't want to repeat again. So this one, convolutional neural network, so it's good for classify the image. In fact, the Google teachable machine. So they are using the CNN, and then later on they want to speed up the whole process. So they use the StreetNet. So it's a simplified version of the CNN. So it's good. So their performance, their performance to find the feature within the image is good. And finally, we have lots of the we have lots of the different network structure. So what we have learned is only this part. Okay. So yeah, we say it is a feed forward or it's a feed forward network. So can you see that is the easiest or most simple way to understand the methodology and understand the mathematics. So if you want to drill down, so there are lots of a family of new network, a family of the CNN. So there are lots of different network suit for different real case example, real case application. So yeah, you can learn more. And of course, because it's training and because it's marked by human, mark the label by the human. So definitely we can affect or we have the responsibility for all the data, right? So here is one of the good example to we think about the accuracy of the AI model, and then we think about the ethical questions. So same image, right? And then only the color of the hand is changed, but the result is different. See that? See that? So that is the problem. And then we are we right now we recognize this is a problem, and then we will start to have more and more chance or more and more ways to report this kind of problem and improve this kind of problem.